Hi, this is part 11 of completing the residential heat loss and heat gain worksheet. This video will discuss ventilation heat loss and heat gain. Near the back of the worksheet you will notice this equation. Start off with a constant. In this case, because we're doing an imperial calculation, you're going to use 1.08. Next is the PVC. This is the principal ventilation capacity. This is determined by the number of bedrooms in the house. In our example, we have a 4-bedroom house, and so if you look at this table, you'll see that 4 bedrooms requires a minimum of 75 CFM ventilation air. If you do not have this table, you can go to Blackboard and look in the building code for HVAC and download the Word document ventilation 9.32, and in that document you will also see this table. Please be aware though that the table in 932 is in metric only, liters per second. However, simply multiply liters per second times 2, and that will give you the required CFM for the number of bedrooms. Once you've determined the PVC, you would input your delta T, and then next is the Hrv efficiency. In our example, we were using this particular Hrv, and we found that the sensible effectiveness at 32 degrees Fahrenheit and SRE was 76%, and so 1 minus 76% leaves us with 0.24. So this helps us reduce the amount of heat loss due to the efficiency of the Hrv. So we have a heat loss due to ventilation of 1,517. In the case of our heat gain, you would use the same constant, the same PVC, the delta T for the summertime, but now you've got another factor called an ETRE. This is short form for Adjusted Total Recovery Efficiency. Now, as it happens, HRVs do not have the ability to remove latent heat. So an HRV does not have an ATRE value. Only ERVs, energy recovery ventilators, have an ATRE value. So since the building code only mandates HRVs, you are not required to install an ERV, but ERVs would have their place in certain applications. Since an HRV does not have an ATRE value, you would simply substitute 0 for the ATRE value, and so it becomes 1 minus 0, so it would be 1. That leaves us with 1,054 BTUs.